Hi, Mark Chisholm here with another STIHL arborist pro tip. In this video, we're going to take a look at the amount of force we impart on a crotch or on an anchor point based on the choices we make with the techniques and the gear we employ. What I'm going to do is set up a series of different climbing configurations, measure the stress we put on anchor points, and hopefully use this information to ensure that we're making good decisions out in the real world. And to do that, we're going to use this Rock Exotica Enforcer, which is a load cell that'll tell us the amount of force we have at our anchor point, transmit that data to a phone or to a tablet, take that information to develop some guidelines to improve climber safety. All right, so we have one load cell set up in the tree to simulate a canopy anchor climbing SRT. We're measuring my weight as I'm sitting still right now with the full harness on, no extra gear, just ascending gear, and that'll be our base point for how all the other force is calculated. Then I'm going to climb up SRT ascension and see if that spikes our peak force, which we know it will, and see where that spike goes to. Okay, we just did an ascension with a canopy anchor, and it looks like the peak force spiked to about 316 pounds. So it was quite a bit more than I weighed in a dead hang, which we expected. All right, so for the next test we're gonna use a basal anchor and have the rope running through a pulley in the top of the tree and back down. We have a load cell at the base, a load cell on the top of the tree, and as I'm sitting here right now, this load cell at the base is reading about 180 pounds. So we're expecting quite a bit of force on that top point. Let's give it a run. All right, on that run with the basal anchor, we got a peak load at the top of about 540 pounds. Quite a big difference from the 180 down at the base. Just like we expected, really, but that's a good spike. Okay, now up in the canopy, we have the exact same setup as the second climb, only I added a little friction up top with the rigging wrench on my side of the line. See if that changes the force any. Okay. The peak load now says 378 pounds. If you remember the last time using just the pulley, it said 540. By adding this rigging wrench here, putting force, a little bit of friction on the downward side, which is the side I'm climbing, reduced a lot of load up here in the canopy. It's pretty interesting. All right, now what I'm gonna do is I'm gonna set up a redirect, and we're gonna set up the load cell on the redirect as well to see how this anchor point and the redirect we set out here is going to share the load, or maybe not. Now, we're working from a redirect. Let's see how that top canopy works now. With some dynamic movements. Should be fluctuating quite a bit, moving around the tree like this. But this is real life work scenario right here. This is what we do with redirects and such. Sometimes some big swings. It'd be interesting to see how these forces are changing. As I'm fluctuating right here, it's going from 180 to 240 pounds just from my movement here. Quite a big difference. All right, so this is what we found today. I weighed roughly 215 pounds, climbing SRT on a canopy anchor, put a load of about 316 pounds on the anchor, double staticked where I ran the rope down and was hanging in a free hang was 415 pounds. The basal anchor said 180 pounds. The peak force when climbing reached 540 pounds. When we used a wrench in the top to add some friction and reduce some force, the peak force only went to 378. And then when I installed a redirect, the anchor said 384, the redirect said 204. All right, well, hopefully this information is useful to you as it is for me. And if you have some ideas for tests you want us to do or more tip ideas, leave your comments below and we'll get to them.